Several ways to do this one. This one is a periodic, right? It starts from 0 and it goes 1, -1, 2, -2, 3, -3, right? So visually it starts from 0 but it goes 1, -1, 2, -2, 3, -3, and so on. So I'm going to manipulate the sine function. Okay. So sine of, we know that sine of pi over 2 is equal to 1. So I'm going to write pi over 2n. Okay. So if it was 1, it'll give you 1. Great. If it was 0, it gives you 0. Great. Okay. If it was 2, okay, if it was 2, it'll give you 0 instead of -1. So sine function at pi over 2 is 1. At 3 pi over 2, 3 pi over 2 is -1. So perhaps I can adjust this to 2n minus 1. So that when it's 2, you get 3 pi over 2 to get -1. So far I made it to here. But next, I don't want it to be 1 again. I want it to be 2 now. And to adjust for that, okay, we need to multiply this here by a value. Okay, so I'm going to introduce a new symbol here called a floor function. So if you have a floor function of n, what this does is that it gives you the greatest integer that happens before n. So for example, if I have floor of 4.1, this is equal to the greatest integer that happens before, to the left of 4.1 is 4. Floor of 6.7, it's 6. Okay. 0.7, it's 0. Okay, that's the greatest integer that happens before this value. So if you get our term number and divide by 2, so for the fourth one, if you put 4 in here, you get 4 divided by 2, which is 2. So floor of 2 gives you 2. A floor of 5 over 2 is also 2. And then floor of 6, right? 6 over 2 is 3, so this will give you 3 sine of the correct value. So this will give us, this is a general term for that. Now this is a pretty fancy formula. This is not the only answer, right? So if you're allowed to use, for example, the piecewise function, we can do this, right? 0, let's see, 0, -1, -2, -3. So that just goes down by -1, right? If you skip every other one. So that's the first term, third term, and so on. Okay, so we want to think about separately the first term, the third term, right? So first, third, fifth, okay. The first term is 0, then -1, -2, and so on, right? So how can we get, when we plug in 1, how can we get 0? How can we when we plug in 3, how can we get -1, and so on? So there's skipping 2 terms. This is 2d, right? 2d again. So 2d is equal to -1. So d is equal to -half. So Tn will be 0 plus n minus 1, right? -half. Okay, or -m minus 1 over 2. So in here, if you plug in 1, you do get 0. When you plug in 3, you do get -1. So it's minus n minus 1 over 2. And this is when n is, right, odd. It's an odd number, the odd term. What about the even terms? So even terms, when it's second term, fourth term, sixth term, right? It's 1, 2, 3. Again, 2d is equal to 1, so d is equal to half. So Tn here is going to be 1 plus n minus 1 times by half. So it's 1 plus half of n minus half. So it's half of n plus half. Or n plus 1 over 2. n plus 1 over 2 when n is even. Okay, that's slightly easier, but also kind of fancy because it's a piecewise function.